I'm going to be discussing Roger Sperry's split brain research. Now, this was accidentally discovered when he was performing surgeries on epilepsy patients. He wanted to help relieve them of their seizures by severing the corpus callosum. However, by severing the corpus callosum, he severed the connection and thereby the communication between the left and the right hemisphere. This then led to future research regarding lateralization and hemispheric function in a brain that was essentially split. He worked alongside other researchers that were dealing with animal research regarding this. In this research, they dealt with, specifically that I looked into, cats and monkeys, where they would sever the corpus callosum as well as the optic chiasm. In the cats and monkeys, body control functions were ipsilateral to the brain. So the left side of the body would be projected to the left hemisphere, and the right side of the body would be projected to the right hemisphere. In their research, they were able to discover that in the split brain of an animal, when performing a task on one side of the body or to one hemisphere, if they tried to replicate the results on the other side of the body, the animal was not able to complete the task and struggled greatly with it. This was due to the fact that one hemisphere knew what the solution was to the problem and how to do it, but because there was no way to communicate it to the other hemisphere, the other side of the body would not be able to complete the task. Eventually, they moved on to humans, where only the corpus callosum was severed, and body control functions were contralateral to the brain, so the right side of the body is to the left hemisphere, left side of the body, right hemisphere. Or through their research, participants were instructed to look at the center of the screen where a crosshair was, and an image or item would appear on either side of the screen, and they were instructed to verbally identify the item. What they discovered was images or words that appeared on the right side of the crosshair, participants were able to verbally identify them and they understood why they were identifying them the way they were. However, if it was on the left side of the screen, participants did not see it and believed that nothing was on the screen for them. But if they were given a list of words or pictures to pick from, they would be able to successfully identify it without understanding why they were identifying it. They just knew that that was true to them. Further research eventually proved that the left hemisphere being logic and the right being creativity was just a myth, and that the real reason was the left hemisphere controls verbal, linguistic, and sequential processing, while the right hemisphere does everything else that's nonverbal and non-linguistic, involving things like facial recognition. This research ended up proving that each hemisphere ends up turning into its own brain, and it has its own way of functions, memories, and moving through daily life, as well as other processes. For my project, I decided to do two separate things, the first being a survey. I asked questions about if they knew who Roger Sperry was, if they knew about the left and right brain, what they knew about it, contralateral controls within cats, monkeys, and humans. For if they knew who Roger Sperry was, 92.7% out of 55 responses responded no. Only 7.3%, or 4 out of 55, said that they knew who Roger Sperry was. When asked if they know about the left or right brain, 94.5% of people said yes, while 5.5% of people said no, so only 3 people said no. This was a little surprising to me as I learned about the left and right brain in high school, so I understood it as something basic that most people learn, but I then left an open-ended question asking what they believed the left and right brain was. A total of 49%, or 27 participants, believed that either the left, right, or one of the hemispheres dealt with logic or creativity, while the other did whatever the other was. A total of 7.27%, or 4 people, believed that the left was involved in language and the right was involved in emotion. 4 people believed that the left logic, right creativity belief was a myth, so only 7.27%. Then there were 16 responses that did not fit into a set category. So those 29.1 responses involved things like abstract versus logic, STEM versus art, different body functions, major inner workings versus minor inner workings, and limb control. Out of the 55 responses, only 8 people mentioned contralateral control, 1 person mentioned ipsilateral control, 3 people mentioned that both hemispheres work together, and only 1 person mentioned the corpus callosum being the connecting point for both hemispheres to communicate with each other, and that severing this would stop seizures going into the brain. Only 2 people said the more right answer, which is that the left involves language, sequencing, analysis, and logic, while the right involved spatial and visual. This was very interesting to me as almost 50% of people still believe the myth that left is logic and right is creativity. And while one could argue that technically it's not wrong, it's still not the right answer. Many of the functions that happen in the left hemisphere can be connected to logic, and many of the functions that happen in the right hemisphere can be connected to creativity. But saying that the left hemisphere is logic and that the right hemisphere is creativity would not be the correct answer. After the open-ended, I asked questions regarding brain similarities and contralateral control in human, cat, and monkey brains. I first asked if people believed that in a human, the body functions correlated to the same side of the hemisphere or to the opposite side of the hemisphere. 89.1% of people said it was the opposite, while 10.9% of people said it was the same side. In the brain of a monkey, 85.5% of people said it was the opposite side, while 14.5% of people believed it was the same side. In the brain of a cat, 56.4% of people believed it was the opposite side, while 43.6% believed it was the same side. I then asked questions like if a human brain was similar to a monkey brain. 92.7% of people said yes, while 7.3% of people said no. When asked if they believed a human brain was similar to a cat brain, this was the most split statistic I have in my entire survey, where 50.9% of people said yes, while 49.1% of people said no. When asked if they believed a monkey brain was similar to a cat brain, 52.7% of people said yes, while 47.3% of people said no. This was an interesting look at these statistics for me because if you believe a majority of people say contralateral control happens in all 3 of these, it would feel safe to assume that they would agree that all 3 brains would be similar to each other. But a thing that threw a wrench in that for a lot of people was introducing a cat brain. For a human and monkey, they were mainly on the same page, but with the cat, that would consistently bring the statistics down into the 50s. So that was an interesting point I gathered from this. The final question was asking if you were an epilepsy patient and you were questioned by a researcher to have surgery performed on your brain to possibly cure your seizures if you were to do it. 69.1% of people said no, they would not take the surgery, and 30.9% of people said yes, they would. This was a shocking statistic for me, as personally, I would not let someone cut into my brain based on the possibility of it curing my seizures. But according to 30.9% of people, or 17%, they would take the risk. So it was just an interesting thing to consider that something that seems so scary and threatening, there is a decent chunk of people, at least roughly a third of people, who would take the risk. And I thought that was interesting. For the second half of my project, I decided to make model brains. I had to change them last minute, so they're not fully ready, but a picture will be here of each brain individually. Things had to be changed last minute. I wasn't able to do it the way I wanted to, so things had to be changed. But I decided to do the left hemisphere of a human, a monkey, and a cat. The purpose of this was to show how similar these brains are while being different at the same time. The sizing, I tried to keep it as close to real life as possible. However, a lot of different sources said a lot of different numbers, so I went with the numbers that appeared the most. So this is roughly the size of a left hemisphere, roughly. And the purpose of this was to show the inner workings of the left hemisphere while also showing a detachable corpus callosum. The point of this was mainly just for a visualization of what was going on. In my research, I saw a lot of videos or 3D models explaining what Sperry was doing, and it was very fascinating to me, and I wanted to just have a model to showcase it. Here is an example of the monkey one, where again, everything is gonna be painted a monochromatic color scheme, so different shades of the same color, minus the corpus callosum that will be a contrasting color to showcase where it is. In the monkeys and cats, there will also be an indicator for where the optic chiasm is, as that's also part of the research that they did with the animals. And that is my research.